Might Proxima b, sooner or later, be one more Earth-like planet? These are speculations everyone keeps making. The journey for an habitable planet and extraterrestrial life on various planets is something individuals are enchanted with. There have been various theories, and the truth that there have been signals coming from Proxima b makes people acknowledge there is something else to it. Regardless of these huge numbers of signs, we still apparently can't decide whether these are messages from the planet or simply rehashes of our own. Scientists often bring about resonances in seeing if these signs are truly from Proxima b. Analysts want to determine whether extraterrestrial life exists. As of late, the James Webb Telescope distinguished artificial lights on Proxima b. If you're excited about learning about various planets and our advancement in finding alternative life, subscribe to our station. We make content about space and examine advancements in science. If you like this content, comment below and share this video with your friends. Now, how about we return to our video? Proxima Centauri, around 4.2 light-years from our planetary system, is a weak little star classified as a G-type. This star is known as Proxima Centauri. It was named Alpha Centauri in 1835 by Johann Bessel, derived from the stars ascending around early evening when a couple of celestial bodies, like the Moon and the Sun, were in an orderly fashion. Proxima Centauri is otherwise called Alpha Centauri A or Alpha Centauri B. It is a single star system with 4 primary stars in a line. Proxima Centauri is at the center of this system, isolated from the 4 stars. There are 2 weak minute companions, Alpha Centauri b and Alpha Centauri c, which make up most of the mass, but are too faint to be seen by the unaided eye. The system is found 23 light-years from the line of the famous Crux asterism in the constellation Centaurus. Despite the fact that Proxima b is a rocky planet, there is still hope that it could have extraterrestrial life. The quest for another life out there has led scientists to Proxima b. They believe the similarities to Earth's size and its distance from its small star make it a plausible candidate for planets that can accommodate life. While these are speculations, there is hope that there might be a reality to them. There is much to learn about Proxima b and the orbit it takes, so stay tuned and keep watching. You can also check out some of our other content related to extraterrestrials. Do you genuinely believe there's another life out there? Leave a comment down below. What interests the majority about Proxima b is its comparability to Earth. Studies show that Proxima b is an exoplanet that orbits an M-type star. Its mass is considered 1.27 times that of Earth. Moreover, Proxima b takes 11.5 days to complete one orbit of its star. It was discovered in 2016, and many scientists are concentrating on it. Despite the fact that Proxima b seems like Earth, specific elements make it less hospitable. For one, the planet is too close to its star and thus continues to receive extreme ultraviolet radiation from the star. It is estimated to be generally more intense than the radiation we get from the Sun. This radiation is sufficient that it strips away even the lightest hydrogen particles, and over time it does the same to oxygen and nitrogen. While many individuals could argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to it than meets the eye. Distance doesn't account for whether there is water on the planet. There is also no evidence of an atmosphere that would be conducive to life. Earth's atmosphere makes it suitable, while Mars doesn't. The right atmosphere makes it feasible for ecological regulation and a water-friendly surface. It also protects living organisms from harmful space radiation. If you're with us up until this point and haven't subscribed yet, take a moment to hit the subscribe button. It makes it easy for us to continue making content like this that you'll love. Now, let's see why people think the James Webb Telescope will help us determine whether there is life on Proxima b. The James Webb Telescope was launched in 2018 after being delayed since 2011. Many changes had to be made to ensure it provided accurate images during its creation. Webb explained that if a planet like Proxima b could absorb light from its star, it could also emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on the surface of a planet and search for patterns that could confirm if the planet has water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that by being above the atmosphere, they don't have to look through the moving air to see deep into space. Consequently, they get a better view of what occurs outside the solar system than most ground telescopes can achieve. Another benefit is that weather changes on Earth don't affect them, and astronomers can be sure they're getting a clear reading. The main disadvantage of having a space telescope is that fixing it is expensive. If something goes wrong, there have been instances where a minor defect in a space telescope required a full mission into space to fix it. Such costs make observing planets like Proxima be difficult with the James Webb Telescope since it has been launched over 1.5 million kilometers away, farther than any human has ever traveled. Rescue missions are impossible. The James Webb Telescope comes with a larger mirror, allowing us to see back to the beginning of the universe, nearly 13.7 billion years ago. The further away an object is, the further in time we get to see it. The reason for this is that light takes time to travel. The capacity of the James Webb Space Telescope to see the universe in a longer wavelength in infrared light means we get to see more distant galaxies in our universe with more clarity than was previously possible. Consequently, observing planets like Proxima b has become easier, as it has pushed the light out of the visible spectrum and into the infrared. Tabor and Bend have a scale for artificial light, which shows how the sun illuminates and reflects the day side of the planet. At 0% on the scale, one would expect the planet's night side to be completely dark, while at 100%, it means the planet's night side is just as bright as the day side. There has been a speculative civilization on Proxima b using this kind of light, and most experts believe it resembles ancient times on Earth. Studies show that if the night side of Proxima b reaches a brightness of 5% of the normal day side, then the James Webb Telescope could detect the artificial light by 85%. If the light reaches 9%, the telescope would detect up to 95%. Although 5% light seems like a small number, we're talking about light from a star like Proxima Centauri. Compared to our sun, Proxima Centauri's light is much dimmer, but we still have a lot of light from our star. This basically means that even at 0.1% of brightness, we are still reflected in the starlight. In other words, if Proxima b has any human civilization that is using artificial lighting like Earth, the James Webb Telescope may not be able to detect it. The stars would need to be around 500 to 1,000 times brighter. This scenario is unlikely, since Proxima b orbits so close to its host star. It's quite possible Proxima b might be tidally locked, meaning one side of the planet constantly faces the star while the other remains in eternal night. Living on a tidally locked planet would require focusing on illuminating the night side and using very bright orbital mirrors to reflect sunlight from the day side to the night side. These are theories made by Tabor and Bend, and it has yet to be proven whether they are valid. The planet's illumination should be visible from space and is known as airglow. Many people can't help but wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. Airglow occurs when particles and atoms in the upper atmosphere produce light to release excess energy. On Earth, airglow can happen when atoms and molecules are ionized by sunlight and capture free electrons. The glow resembles an aurora, except that auroras are driven by high-energy particles from the solar wind. The airglow is driven daily by solar radiation. Since the James Webb Telescope's launch, analysts have been questioning whether it is sufficient to observe distant planets in remote galaxies. Despite being the farthest space telescope ever launched, it still provides very limited data needed to find planets with life in other galaxies. Consequently, there have been discussions about creating larger and better telescopes. These endeavors are often costly and involve a lot of experimentation. The James Webb Space Telescope's launch was 5 years late due to these issues. Therefore, it is challenging for most scientists to develop better technologies that can be launched further into space. Nevertheless, the James Webb Space Telescope's results are promising. Soon we could know whether there is life on Proxima b and other planets. While work is still being done on additional telescopes, the expected completion and launch of the HABEX, Habitable Exoplanet Observatory, will revolutionize space exploration. The estimated completion time for HABEX is 2035, with a launch shortly after. HABEX will be sensitive to all planets in the universe. Although its primary goal is to search for Earth-like planets, Its cutting-edge technology will enable it to measure the spectra of most planets and determine if they are habitable. HabEx is also expected to have a wide range of cosmological capabilities, allowing it to study the earliest times known in human history, gather data, and understand the life cycles and deaths of massive stars, as well as the factors that support life as we know it. Despite the challenges faced in space exploration, the advancements in technology and our understanding of distant worlds continue to grow. As we develop more sophisticated telescopes and observation methods, we inch closer to answering the fundamental questions about life beyond Earth. The exploration of Proxima b and other exoplanets is just the beginning of a broader search for extraterrestrial life. Scientists remain hopeful that with each new mission, we will uncover more about the conditions necessary for life and the potential for discovering intelligent civilizations elsewhere in the universe. As we look to the future, the quest for understanding our cosmic neighbors will undoubtedly shape our view of our place in the universe. Stay tuned for more updates on our findings about Proxima b and the exciting developments in the search for extraterrestrial life. If you have any thoughts or questions, feel free to share them in the comments. Your engagement helps us continue this important dialogue about our universe and what lies beyond.